Hello, everybody. This video is just going to give a couple more examples from our assignment from yesterday, the Graphing Rational Functions version 1. Very similar to the example you already had, but in case you needed to see a couple more, I'll do a couple more for you, and then that'll be it. You can finish that assignment up. All right, I do want to do number 4 with you. And so you see the equation there. So y equals 2 over x minus 1, and then minus 1 on the end. Remember, three things are different from the parent function. It is stretched a bit because of the 2, and the whole graph is moved to the right 1, and it also is moved down 1. Okay, so remember on these rational functions, we're going to put in the asymptotes first before we worry about points. So if you look at that equation, normally our vertical asymptote for the parent function would be at the y-axis, but now it's going to be moved to the right 1 because of the x minus 1 there. So I'm going to put in that vertical asymptote right there. X cannot be 1. So you might as well write that equation then right now. X equals 1 is a vertical asymptote. The graph will not touch that. Then look at the minus 1. That means the graph got shifted down. So that horizontal asymptote, which used to be the x-axis, is now moved down 1. So it's down here. This is a new horizontal asymptote. And that equation, which they're asking for, is y equals negative 1. Remember, asymptotes are lines. They have equations. Okay, so that's that. The only thing we have to do now is choose a couple points to find out where the branches of the graph are. So we're going to make a little table for that. There's 2 branches that are separate from each other. So I'm going to choose a point for x, which is to the right of that vertical asymptote, which makes it easy to calculate y. So it looks like 2 is a good choice for that. So just do the math with me, mental math there. I'm plugging in 2 for x. So 2 minus 1 is 1. 2 divided by 1 is 2. And then 2 minus 1 is 1. So 2 is going to go with 1. That's going to be a point on that branch of the graph at 2, 1 right there. Okay, so that knowing that right now tells us where that branch is. And so it's going to be that boomerang-shaped graph. And remember, it's not going to cross either the vertical axis or the horizontal axis. So it's going to have to look like this. So without needing to make any more points in the table, we know that branch of the graph is right there. And if you need a better accuracy, of course, you could choose different numbers for x. Okay, so now we also want to pick a number to the left of that vertical asymptote. So less than positive 1. Looks like 0 is a good choice for x. I'm looking at the equation to help me with that. So if I plug in 0 for x, I got 0 minus 1 is negative 1. So do the math there. It's 2 divided by negative 1 is negative 2. Minus 1 is negative 3. So plugging 0 in for x in the equation gives negative 3 for y. So 0, negative 3 is going to be a point on our graph. So that's going to be right here. And again, it's a boomerang-shaped graph, and we know it cannot cross either the vertical or horizontal axis, so we know it's going to have to be squeezed in right here. And that'll be your graph. Okay, again, the directions tell us to give the asymptotes, which we've done already, and also the domain and range. And remember, the domain and range are easily picked out from the asymptotes. So the domain of your graph is, what can x be? Well, x can be anything you want, except where you got a vertical asymptote. So x can be anything except for positive 1. So we just say the domain is x is not equal to 1. Graph can't touch that. You can see why x can't be 1. If you plug 1 in the equation, you get division by 0. Can't divide by 0. Okay, look at the range. So we can see that there cannot be any point touching that horizontal asymptote where y is negative 1. So we say y can be anything you want except for negative 1. You can see that graph goes up forever and a graph goes down forever, but nowhere is that graph, either branch, equal to negative 1. So there's your domain and range and your sketch. Okay, just one more if you still need it. Number 10. So this time your equation is y is equal to 3 over x plus 1 with a +1 on the end of the equation. Okay, remember with rational functions, we like to kind of position them first using the asymptotes that we know and then go for the points later. Okay, so we know that normally the parent function would have its vertical asymptote at the y-axis, so we're going to move that over to the left one because that's x plus 1 there in the denominator. So here's your new vertical asymptote, got moved to left 1 because of the x plus 1. And that +1 in the end moves all the points of the graph up 1. So instead of being on the x-axis for the horizontal asymptote like it was for the parent function, it's going to be moved up 1. So there in blue are your two asymptotes for this graph. We might as well write their equations right here. So this is y equals 1 for that horizontal asymptote, y equals 1. And that vertical asymptote has an equation, x equals -1. And again, we've got to make a little table to figure out where are the branches of the graph going to be. And by the way, some people are probably thinking, well, I know where they're going to be. Well, they do move around for different equations. We have version 2 and version 3 of this, so get a system here. All right, so I'm going to choose a convenient point, which is to the right of the vertical axis there, vertical asymptote, sorry, which it looks like 0 is going to be a good choice for that for x. So plug 0 in for your equation for x. So 0 plus 1 is 1, 3 divided by 1 is 3, plus 1 is 4. So 0 is going to go with 4. So that gives us a point on the graph 1, 2, 3, right here. Okay, so again, we know that that graph is trapped. It's a boomerang-shaped branch, and it's trapped in between the vertical and the horizontal asymptotes. So the only way we're going to be able to sketch it is like this. Okay, let's choose a convenient point, which is going to be less than that vertical asymptote, so less than -1. So it looks like -2 is going to be a good choice for x. So plug in -2 for x. So -2 plus 1 is -1. 3 divided by -1 is -3, plus 1 is -2. So -2 is going to go with -2. So that point's going to be right there. And again, it's trapped in between the vertical asymptote and the horizontal asymptote. So there's only one way it can be. It's boomerang shaped. And it's going to have to go through that point that we just calculated like this. And there you have it. So we've given the graph, we've given the two asymptotes. Now they want, as usual, the domain and range, which are easy to find from the asymptotes. So the domain is what can x be? Well, x can be everything you want it to be, except look at your vertical asymptote. X cannot be -1. So we just write the domain x is not equal to -1. And again, you can see that from the equation. X, if you put -1 in for x, you cause that fraction to be dividing by 0, which is not allowed. So x cannot be -1. And the last thing we have to answer about this question is the range. Again, look at the horizontal asymptote this time. Y will never be 1. You can see that that is a horizontal asymptote. So y can be anything you want except for -1. So we just write y is not or +1. Y is not equal to 1. So there you go. You got 3 examples total for version 1 of graphing rational functions. Go ahead and finish that up, and then the next video will be on graphing rational functions version 2, and there's a little bit different twist to that. So you can look forward to that. Okay, enjoy.